Welcome to the next lab session of Analysis and Design of Algorithms. Myself, Mrs. Madhunagraj, Assistant Professor, Department of CSE Data Science, ATME College of Engineering, Mysore. So let's study the next program, that is Program 5, the program in C to obtain the topological ordering of the vertices in a given diagram. So here we are going to sort the vertices in an order, so which is called as the topological sorting. So topological sorting is nothing but, so it is done for the directed acyclic graph, that is the graph should be directed as well as it should be acyclic. That means there should not be any cycle formed in the graph. So it is the sorting of the directed acyclic graph in a linear order of the vertices such that for every directed edge UV, that is from U to V, always the vertex U will come before the vertex V in the ordering. So that means if I have a vertex 1 to 2, then always in the ordering or sorting, so the vertex 1 should come, later on the vertex 2 should come. So that is topological sorting. So topological sorting for a graph is not possible if the graph is not a directed acyclic graph. That means always it is done for the directed acyclic graph. So if it is not a directed acyclic graph, then the sorting cannot be done. So consider this particular graph. So always the sorting starts from the vertex where the in degree is 0. That is, we will start from the node where always the in degree of the vertex is 0. So here you can see that we have the two main vertex, that is 5 and 4. So which is having the in degree 0. So we can either start the sorting from vertex 5 or we can start from vertex 4. So usually there can be more than one sorting in a graph. So it can be one or more than one depending upon the graph. So here the output is 5 and then 4, 2, 3, 1 and 0. So each time when the vertex is visited, so we are going to remove that vertex and we are going to place it in the sorted array. Like that, we are going to remove one after the other vertex and then we are going to get the topological sorted array. So here you can see each time whenever we consider the vertex which is having the in degree 0, we are going to remove it and place it in the sorted array. So the order goes like this: 5, 4, 2, 3, 1 and 0. So let's see step by step. So how exactly we are doing this. So we are going to start from the DFS, that is we are going to apply DFS method for each of the node. So initially we are going to consider a stack and then we are going to perform the DFS function. So here starting from the node 0, so because it is having the 0 adjacent nodes, so we are going to consider that node first and then we are going to push that node into the stack. Next we are going to consider the node 1 because it is having the minimum adjacent nodes next to 0, so we are going to consider that node and push it in the stack. And then we are going to choose node 2 because it is having the minimum number of adjacent nodes after 0 and 1. So you apply DFS for node 2. So whenever we apply DFS to node 2, so you are going to push all the adjacent nodes. So here we are going to push 3 and then we are going to push the node 2. Later on we are remaining with node 4 and node 5. So first you are going to consider node 4 and then we are going to consider node 5. So in other order you can either consider node 5 first and then node 4. So because we get two sorted arrays, so any of the two cases can be considered. So finally we are going to pop out the elements or pop out the nodes from the stack in the order in which it is being placed. And when the popping is done, so we are going to print that value as it is. So each time when you pop out, so that node will be placed into the sorted array. So that is 5, 4, 2, 3, 1 and 0. So now let's see how this is implemented using the C program. So this is the program which shows how the topological sorting is done, how it is implemented using the C programming language. So starting with, let's start from the main function. So main function, so you have the variable ij. So next it will ask enter the number of nodes. So we are going to read the number of nodes. Next, it will ask to enter the adjacency matrix. So you have to mention the adjacency matrix. So for I is 0 to n, that is from 0 to all the nodes, so we are going to read it. That is in the adjacency matrix, 0 to n columns and n rows. And then we are going to read the values. After that, we are going to call the topology function. So what happens in topology function? So here we have the variables, different variables. So here we are considering the top is equal to -1 because initially the stack will be empty. So the nodes, so the empty stack, so no nodes will be added into the stack. Next, call the find in degree function. So in find in degree functions, we have three variables j, I, and sum. So the loop runs from 0 to n. Initially, the sum value is assigned to 0. Next, the I value runs from 0 to n, and each time whenever there is an edge from one node to the other node, that is a of ij, so there is any value 1, so that time it will be added and it will be assigned to the value sum. So each time whenever the sum value is added, that will be added into the in degree of that particular node. So this indicates how many in degrees are there for each of the nodes in the graph. So this value, it can be 0, 1, 2, 3. So based upon the in degrees for that particular node, so this value will be assigned. So after we get that value, so next the loop runs from 0 to n. And then if in degree of I is 0, that means, so we are considering the nodes which is having the in degree 0. So that node will be added into the stack. So that means the 0 in degree node will be added first into the stack. Now, while top is -1, that is if the stack is empty, then you are going to, so if it is not equal to -1, sorry. So if it is not equal to -1, that is if it is not empty, then the value which is there or the node which is there on top of the stack, so that will be popped out and it will be assigned to the value u. So similarly, we have one more loop that runs from v is equal to 0 to n. And next we are checking the condition if a of uv is 1. That is, if in the adjacency matrix the value is 1, then the in degree will be decremented by 1. That means we are going to remove that value from the stack. So the in degree value will be decremented by 1. So each time we are going to perform this value. So each time when the in degree is decremented, then we are going to check if the in degree is 0. So if it is 0, then we are going to add that v into the top of the stack. So like that, we are going to add all the in degrees into the 0, and then we are going to pop out one by one, and then we are going to place it into the topological sorted array. So lastly, we are going to print the topological sequence. So from 0 to n, we are going to print all the nodes which is there in the sorted array. So now let's run and see the program. So how exactly it works with the input. So it is asking enter the number of nodes. So we have totally 6 nodes from 0 to 5. So enter 6. So enter the adjacency matrix. So for the same graph which we have seen in the example, so we'll enter the adjacency matrix for the same graph. So from 0, there are no outgoing edges. So it is 0, 0 for all the edges, 1, 2, 3, 4, 5, and 6. So for all the nodes, it is 0. And next from 1 also, we don't have any outgoing edges. So 0, or there is no direct path from 1 to any of the nodes. So it is 0. Next from 2. So from 2, we have only one directed path, that is to 3. So from 0 to 0, 0, 1, 0, 2, 0. To 3, we have only one path, and 4, 0, and to 5, it is 0. And from 3, we have only to 4. So for all other things, it is 0. And finally, next from 4. So from 4, we have two edges to 1 and 2, sorry, 0 and 1. So we have two edges, and for all other edges, it is 0. And lastly, from 5. So from 5, we have to 0. So for 0, we have one path, and for 2, we have one more path. So all other values, it is 0. So now you can see, so we got the same sequence 5, 2, 3, 4, 1, 0. So which is there, like we sorted in the example. So the adjacency matrix, so based on the adjacency matrix, the path which we have given, so we get the sorted array. So 0, 0, 1, 0, 0, 0, 0, 1, 0. So 1, 1, 0, 0, 0 and 1, 0, 1, 0, 0, 0. So this is how the topological sorting is done. So based upon the nodes. Thank you.